Let's talk a little bit more about current, and we'll start with this simple circuit. I've got a battery, a source of potential difference, and a resistor. As we talked about last time, in this simple circuit, current is going to flow. The battery is producing a potential difference. One side is at a higher potential than the other side. And what direction does the electric field point? The electric field always points from high potential to low potential. The long line on our symbol for the battery indicates it's the higher potential side. So if the low side is, pick a number, how about 0 volts? Then the other end, the other terminal of our battery, is going to be some higher potential. If this is a 9-volt battery, the other end will be at 9 volts. 9 volts above the lower terminal. If we call the lower terminal 0, then the upper one will be 9 volts. If we call the lower terminal 1 volt, the upper one will be 10 volts. The battery maintains a potential difference of 9 volts for a 9-volt battery. For a 1.5 volt battery, that voltage difference across the terminals is 1.5 volts. You guessed it. In this case, the long line on our symbol for the battery indicates it's the higher potential side. So our electric field points this way. Inside of the wires. And what's going to move in the direction of the electric field? Positive charges, if they could move, would move in the direction of the electric field. Negative charges, electrons, will move in the other direction. So in here I can draw an arrow and label it I for current. So the current in this circuit would be flowing clockwise through the circuit, as I've indicated here with the arrow. Our symbol is I for current. And what is the current equal to? The current is a flow rate. How much charge is flowing past a certain location in a given amount of time? It's just like the current in a river. If you were standing at the bank of the river, measuring how much volume of water was flowing by in a given amount of time, that would be the current in the river. The electrical current in a circuit is the amount of charge that flows by a given location in some amount of time. So it's the time rate of change of the charge. So the units would have to be coulombs per second. And we get tired of writing coulombs per second all the time. So we write A for ampere. The ampere is the unit for current. Let's talk about that resistor for a minute. We just spent a lot of time talking about resistance. We understand that as charges try to make their way through a conductive material, they have some impedance to their flow through the material. They collide with atoms and molecules that make up the material, and it slows them down a little bit. They lose some of their energy as they try to fight their way past those atoms and molecules. And that is what resistance is. It's as if it was electrical friction, very similar to friction acting on something sliding across the floor. The unit for resistance is the ohm, and we use the Greek letter omega. And just as a reminder, for a battery or DC power supply, we use these symbols where the long line represents the higher voltage terminal and the short line represents the lower voltage terminal. Resistor has this symbol, and any place where you just see a straight line, a wire, we assume zero resistance in our circuit diagrams. We assume they are perfect wires. Of course, in the real world, wires have some resistance. So we would add a resistor to our circuit diagram equal to the resistance of the wire if we wanted to take that into account in our calculations. One technique I like to use when I analyze circuits is to get out my highlighter pens and use them to help me spot where the potential changes and where it's the same. In this case, I can pick any place I want to be 0 volts. So how about the lower terminal of one of my batteries? I'll start with 0 volts at the low voltage terminal of one of my batteries. I know that these lines are perfect conductors. That means they are equipotential surfaces. So every place I've highlighted green should be 0 volts. I can call 0 any place I want in this circuit. I'm going to call this 0 volts. Now that fixes my potential at any other place in the circuit. Let's start with our 9-volt battery. We know that the high potential terminal is 9 volts higher than the low potential terminal. And I just defined the low end of my battery to be 0. So that tells me the high end has to be 9 volts. So I'm going to get out my different colored marker and I'll indicate that's 9 volts. That whole stretch there is 9 volts. Now I've got one more section I can highlight, and that's after I go through my 6-volt battery. I know my 6-volt battery maintains a potential difference of 6 volts. So I'm going to highlight this whole section to indicate it's 6 volts. Now I can go and look at each of my resistors. Resistor 1, one end of it, the left side, is hooked up to 9 volts. The right side is connected to 6 volts. So I know I have a delta V across resistor 1 of 3 volts. And I look at resistor 2 and I see the left side is hooked up to 6 volts and the right side is hooked up to 0. So I know I have a potential difference across resistor 2 of 6 volts. Now let's take a look at another circuit. In this circuit, we see a symbol we haven't seen before. This symbol in the lower left indicates that is connected to ground. We'll talk more about ground later, but in a circuit diagram, it means 0 volts. It is defining 0 volts for us. We don't have a choice. We can't define it wherever we want it to be. They've defined it for us. So I'm going to get out my color for 0 volts and highlight all the lines that are 0 volts. Now I'm going to work my way up and around through the batteries. I'm going in the low voltage end of my 6-volt battery. I'm calling that 0. I'm coming out the top of the battery. The high voltage terminal has to be 6 volts higher than 0 or 6 volts. So that section right there represents 6 volts. Now I'm going in the low voltage terminal of my 9-volt battery. And when I come out the high voltage terminal, I have to be 9 volts higher than 6 volts. And 9 volts higher than 6 volts is 15 volts. There's one more section between these two resistors. So I'll get out another color and highlight it. And I don't know what the voltage is there, but I do know it's less than 15 volts. And it's more than 0 volts. That much I know. And in the next video, we'll learn some techniques where we'll be able to figure out what that voltage is and what the current is in this circuit.